My name is Ben Eady, and I'm the online media manager of ModernAnalyst.com, the premier online community for business analysts. I'd like to welcome you to today's webinar entitled Big Data and Toad Business Intelligence. Today's featured speaker is Guy Harrison, VP of Research and Development from Quest Software, now a part of Dell. We also have with us Joanna Schloss, Product Marketing Manager, who will be answering your questions after the presentation. The webinar will last approximately 60 minutes, including the Q&A session, so make sure to submit your questions in advance using the question feature of the webinar software. I'd also like to say thank you to Dell Software for sponsoring this event, and at this time, I'll turn it over to Guy to get us started.
Hi everyone, Guy Harrison here from Dell. I'm Executive Director of R&D for Information Management. I joined Dell only a couple of months ago as part of the Quest acquisition. Quest Software, where I've worked for 14 years. Quest is a systems management vendor. We create software that helps you manage all of your IT infrastructure, whether it be application, database, Windows, what have you. Our best known product is undoubtedly Toad, which is an IDE for database administration, development, and business intelligence, which has millions of users around the world. It's an incredibly popular product. And we've had a lot of fun with the Toad brand over the year. We've had Lord of the Rings Toad, Surfer Toad, Hippie Toad. My favorite is undoubtedly Star Trek Toad. But a few years ago, we started to look at Toad diversifying from its database-centric origins and moving out into more of a future in which data was spread throughout multiple types of systems. So this is from 2010, and you can see this Toad is reaching out to new technologies like Hadoop and NoSQL, and to different platforms, some of which are cloud-based and so forth. And if you look at our positioning for Toad today in 2012, you'll see that Toad now connects to data wherever it might be, whether it's in a relational database like Oracle or SQL Server, a business intelligence system like Oracle Business Intelligence, or a cloud system like Salesforce.com, and all of the new big data systems like Hadoop and Cassandra that we're going to talk about today. So this presentation is a lot to do with big data, and it's impossible to talk about big data without starting with some sort of definition. And when someone like me talks to a group about big data, one of the things you'll hear very often is the 3 or sometimes 4 V's that define big data. And these V's are the V's of volume, the simple fact that the volumes of data that we're having to deal with are increasing, moving up from databases with terabytes, petabytes, exabytes, zettabytes into yottabytes, and whatever comes after that. That there's more variety in the data that we're dealing with. We're dealing with structured data, relational data in tables and so forth, unstructured data in free-form text, data generated by humans, data generated by machines. And that we're dealing with this data at an ever-increasing velocity. The rate at which we're having to accept new types of data and new formats of data is increasing exponentially. And the 4th V that you sometimes mention and sometimes isn't is the V of value, which is to say that business is seeing more and more value, more and more ways to achieve competitive differentiation from these new sources of data. So let's quickly move through some of these V's, and then I'm going to go on a little bit of a sidetrack onto the role of consumer tech into this technology, and then we're going to come back to big data technologies and how it fits in with business intelligence. So volume is kind of the obvious thing about big data. Data volumes have always been increasing. I've been in the information business for 25 years or so now, and it's been true every year that databases are getting bigger. So here's a slide from 2006. Similar to this presentation, we're saying that data volumes are getting bigger. So in that sense, big data is nothing new, but it is fair to say that the volumes of data that we're dealing with are now becoming truly mind-boggling. So on this chart, you can see that the amount of information held in a single human brain, which is about 2.8 petabytes, has been dwarfed for years now by Google. And the amount of digital information generated 4 years ago exceeded the amount of information in all the genes, all the genetic material of all the human beings alive. And now we're hundreds and thousands of times more than that, with zettabytes of digital information being generated every year. And so this simple, although data is increasing year over year and has been forever, we're getting to the points where data is becoming harder and harder to manage just because of the volume. Velocity, of course, is the other aspect of data growth. It's a somewhat inevitable consequence of, excuse me, I'm just having a bit of trouble advancing the slide here. There we go. It's somewhat an inevitable consequence of the size of data. Obviously, if you've got more and more data, you're going to have to, as a consequence of that, have more and more data on a daily basis. But it's not increasing in a linear fashion for a lot of enterprises. We see this very easily in things like Twitter and Facebook. The number of users, the number of tweets, the number of interactions is growing exponentially, making it harder and harder to keep up with traditional technologies like relational databases, which can scale, but they tend to scale in a linear way. You might be able to double your capacity in a single year, but you won't be able to quadruple it the year after, or keep up with this sort of increase in rate of data capture. And then we have the V of variety. And variety is a good way of describing it, but there's another term I like even better, and that's the term that's called the industrial revolution of data. This is a term coined by O'Reilly Media, and I think it captures perfectly what's going on in our industry. So if you think about the industrial revolution that happened in the 1800s, before the industrial revolution, everything was created by hand. And before the industrial revolution of data, all data was pretty much entered by hand. So you had people paid within your organization that were punching data into computers, and they were called things like data punch operators, data entry operators, and so forth. It's a job title that doesn't exist anymore, but it was an incredibly big job title when I entered the industry. But today, of course, we don't have it all entered by hand. It's coming in by people outside our organization, our customers. It's coming in through other channels, like mobile is an increasingly large source of data. And it's not all coming in as text either. Some of it's coming in as spoken voice messages. We've got monitoring systems, sensors, traffic cameras, medical monitors, and so forth. Very soon, we're going to have consumer devices that are literally reading our brainwaves. And if you think about it, our entire house is being wired up and producing data. And wherever we go and whatever we do, we're generating and consuming data in a way that sometimes might seem even a little bit creepy, but it is the world in which we're living in. And a lot of this data generation is actually being created by the smallest computers, which are the mobile computers that we call cell phones. So it's ironic in a way that big data is created a lot by the smallest of devices. So when you think about the modern cell phone, I'm sure most of you recognize that the fact that it's a phone is really almost beside the point. It's a very, very powerful computer that would have matched the desktop configuration of just a few years ago and would really be called, in the 80s, would have been called a supercomputer. And not only does it have all this storage, but it's also got some unique capabilities that can't be found in desktop computers, a camera, location services, and so forth. And we're seeing, as a result of the wider adoption of smartphones and the increasing capabilities of internet on these phones, that internet traffic via cell phone is growing faster than internet traffic via desktop. And last year we hit a bit of a watershed moment where the number of smartphones being sold exceeded the number of PCs. And in the emerging markets like India and China, the number of internet-connected devices is already dominated by cell phones. There are more internet-connected smartphones than there are internet-connected computers. And one of the reasons for this is that there are things you can do with the smartphone platform that you can't do with desktop computers. So because the smartphone has a camera, it's capable of reading a barcode. And because it's connected to the internet, it's capable of looking up that barcode and getting you a price, and perhaps you can even buy it over the internet. It doesn't have to have a barcode. Pattern recognition is getting pretty good, so you can point your camera at a can of Coke and it will recognize that it's a can of Coke. Because it's got a compass and a GPS in it, it can take a pretty good guess at where you are and where you're pointing the camera, so it can look at the thing you're looking at and perhaps identify it. And because it's connected to Wikipedia, it can get pretty much all the information that you could possibly imagine about that device. And because it's connected to social networks like Yelp and Facebook, it can find out what your friends think about the things around you and what other people have thought about the thing around you. An amazing combination of technologies, but we can't really realize all of that functionality while the phone is stuck in our pocket. So there's a lot of work going on now to provide this sort of augmented reality in our everyday life. And early attempts at this look a bit unwieldy. Now, I'd wear that in a flash, but most people would find it a bit lacking in style. But next year, Google Glass will be released, and this is Google's attempt to provide an intelligent heads-up display that will fit over existing glasses or work with a special pair. And you can see there it's got a kind of a little corner, a screen in the corner of that person's eye that's displaying information like maps and so forth. There's a camera there, there's a speaker, a microphone, and it will provide a fairly complete interactive experience for people just as they're walking around. And imagine how much data is going to be generated and how much data is going to be required to provide that experience. And that's not where it stops. There are serious attempts to provide this functionality in a contact lens format. And so we can look ahead to the future, perhaps through the show Futurama, to see where this is all heading. This guy's in the future and he's asking, he's buying an iPhone. He asks the vendor, why do you call it an iPhone? And the guy says, well, just wait till I install it. In it goes. And now he's got a very pleasant heads-up display. And after a bit of discomfort, he looks very happy. And now he's just about to have the earpiece installed. And that looks like it might be a little bit uncomfortable as well. And so we can imagine a future in which literally people are walking around, interacting with everything that they see around them through these sorts of glasses, finding out important information about the people around them and perhaps even the dogs and so forth. And that's half of the big data equation as it reflects to cell phones. There's also an amazing amount of innovation going into how we produce data via cell phones. If you think, or smartphones I probably should say, if you think about what we do most of the time now with our smartphone, we type into a little QWERTY keyboard, and it's very awkward, and I'm sure everyone is frustrated when they have to type anything non-trivial in that way. In fact, for someone of my age, it seems almost exactly like the old key punches that we used before the Industrial Revolution of data. This is the first program I ever wrote was on a system something like this. I would type it out, it would put it onto a punch card, which I'd give to the computer. And so really we haven't come a long way there. And we're seeing increasing innovation though. Apple produced Siri, which is a good example of a voice control system. It's not perfect yet. There are many amusing problems with Siri. Here's a few funny examples. In this case, someone said to Siri, "Siri, call me an ambulance," to which Siri replied, "Okay, from now on, I'll call you an ambulance." And another case where someone said to Siri, "I want to jump off a bridge," to which Siri replied, "I've found some bridges for you to jump off." And so it's not perfect, but interestingly enough, it's getting better. And one of the things with Siri that makes it better is the fact that the data is being analysed in the cloud means that when these mistakes are made, they kind of can be instantly corrected for everyone without a software roll-up, and it can learn from experience as it finds that people did not take that particular response properly. It can go, oh, okay, when people ask me to call them an ambulance, they don't mean that their name is ambulance, they mean they want me to call them the paramedics, which is kind of pretty interesting. Other things that are going on with input, this is a technology called Sixth Sense, in which someone has a camera and a little projector, and the computer can work out what their gestures are through the little things they're working on the tips of their fingers. And this means that they can do things like project a keypad onto their palm and tap on it to make a phone call. Or if they want to take a picture, they can just make a sort of like a snapshot gesture in front of the thing they're trying to take, and the camera will take a photo. And these sorts of technologies are likely to be incorporated into heads-up displays like Google Glass. Of course, the ultimate way to control and the ultimate form of data is mind data, brain data. The idea that we could control a computer directly seems a bit science fiction, but in fact, it's just an engineering problem if you think about it. Psychologists and neuroscientists for a long time have worked out how the brain generates an electrical field and magnetic field, and how we can read that magnetic field to work out what someone's thinking in a very general terms. We can, if they're hungry, if they're sad, if they're happy, and you can control a computer using these things, though the functional magnetic resonance imaging rigs like the one on the right there are pretty unwieldy, and it's hard to imagine walking down the street with something like that. But there's some commercial companies working now on consumer-based helmets that could do basic thought processing, basic command processing, and I'm pretty sure that we'll see them for the next few years, at least in some forms. Here's an example of one that was released this year by a Japanese company. This girl's wearing a helmet, a hat, that has some sensors in it that can at least register her emotional state. And so when she's happy or sad, it records that and it kind of automatically posts it to her equivalent of Facebook. And so you can imagine as people walking around with these sorts of things, generating happiness maps for cities, places where it's fun to go, places where it's not fun, places where people feel unhappy or frightened could be generated. And if you think about the enormous amount of data that we could be experiencing with that sort of stuff, and the marketing potential for knowing where people, what people like when they look at it, again, could be a little bit crazy, but it's definitely a trend that we're seeing. So that was a bit of a diversion in some respects, but I think it proves the point to some extent that the data, the sheer volume of data that's being generated through consumer devices, in particular smartphones, is essential for the experience, and that that the experience really is built upon the data that exists. All of those examples require big data sets in the cloud. Siri has to know what other people have asked for in order to make the best guess about what you're asking for, and your data feeds back into that to build the experience and make it better. So but I mean, that's for consumer, but what does sort of like business analysts, why do we care about all of this data? Well, there's an enormous potential for this data to be mined to get competitive advantage. And there are three kind of core techniques that are used in this sort of big data analytics space. One is machine learning, generating programs that can build on experience. So Siri is an example of a machine learning program because it is getting better and better as more people use it. And the ability to have our e-commerce and customer-facing systems improve in that way is incredibly important to stay relevant in the new world. Collective intelligence is a similar concept. It's when we take the inputs of large number of people to try and get intelligent behaviour. And predictive analytics that we're a little bit more familiar with, that's been a phrase that's been around for a little longer, where we're trying to take data from the past and extrapolate it into the future. So collective intelligence is one of those phrases that's a little bit poorly understood, but really it's something that we all experience in everyday life. So for instance, when you type something into Google, Google tries to work out what you're probably going to type next. So you type, why is the, Google's probably going to say, why is the sky blue? But actually sometimes it comes up with some funny things like, why is the rum gone? Likewise, if you type in where is, you'll find that amongst the many other things that people are typing in, apparently people are typing in where is Chuck Norris. And this seems a bit odd, and I thought it was just a Google joke at first, but in fact the same thing happens with Bing. You type where is in Bing, and as well as looking for their tax refund, people are also trying to find out where Chuck Norris is. Weird, huh? And there's some interesting geographical differences as well. So in the US, in the United States, when you type why doesn't, you get a lot of things about why doesn't he like me, why doesn't she like me, why doesn't anyone like me. It's kind of sad in a way, imagining people typing into Google, why doesn't anyone like me? Now here in Australia, where I live, people are typing, when they type why doesn't, we seem to be trying to freeze alcohol into icy poles. So we must be a lot more hardened, or perhaps we're just trying to drown our sorrows, but it's kind of an interesting experiment to do as you move around the world. But there's serious applications to this as well. So I'm sure you've all experienced the case where you type something into Microsoft Word and the individual words are correct, but in context, it's nonsense. So obviously here, I should have been typing the rain in Spain falls mainly on the plain, but Microsoft Word doesn't care because it's got a very dumb kind of spell checking mentality to correction. Even though Microsoft Word's been around for 20, 30 years now, the spell checker still can't correct simple mistakes like this. But Google, on the other hand, will correct these mistakes instantaneously because of collective intelligence. It's got the data that says that when people make this mistake, they were really meaning something else because they instantly correct themselves. Google notices it and builds up its database about that. And that's a good example of collective intelligence. Collective intelligence is also the basis for most recommendation systems. when you're in Amazon and Amazon recommends things to you, it's based on the things that you bought in the past and the things that other people who've bought similar things have bought that you haven't bought. And it's a very powerful, and I'm sure you understand, a very important tool in e-commerce today. This is my Amazon recommendation. If you're wondering why I've got vampire books and database books, it's because I let my daughter buy books on Amazon. So Amazon's got a very warped idea about what I like. Another thing that you can do with collective intelligence, or that Google does, is to predict flu trends. So when people get sick, they stop typing in "why doesn't he love me?" and they start typing in "why is my nose runny?" And they do that way before they go to the doctor, which means that Google has a much better idea when sickness is erupting in an area than say the CDC. And so you can see here in Google flu trends, you can look at anywhere you might be happening to go, and you can get a very accurate sense of whether there's much flu activity in that location. So all very useful applications. And in every realm of business, there is some sort of application like this that companies are looking for to get competitive advantage. There's almost no industry now where you can say collective intelligence, machine learning, predictive analytics, they're not important. They're just, that industry doesn't exist. In every industry, the companies that are going to get the most competitive advantage have to leverage these sorts of big data techniques to get ahead. And it's a sort of like a sea change in the way in which business analysts are going to be expected to work with data, because we're going to be forced to try to use much more sophisticated techniques. So collective intelligence, I said a few years ago, and a few other people said it too, that collective intelligence was beating artificial intelligence. The old style of artificial intelligence that you might have seen in a movie like 2001, which is a movie that was made in 1969, but which had spaceships, which was made in 1969, predicted that we'd have 10 years ago computers that could talk to us normally, that would be virtually alive, and which would be able to give human-type responses and understand English very well, and so forth. And this really didn't happen, although last year an amazing breakthrough in artificial intelligence came, which is very relevant to big data, and this was the Watson machine that you may have heard about, which won at Jeopardy. Now, IBM had produced a number of artificial intelligence systems, such as Big Blue, which won at chess. And although it's impressive to win at chess, I'm sure most people understand that chess is sort of something you can brute force. If you can calculate enough moves ahead, you can probably beat most players. But Jeopardy is a completely different kettle of fish. In Jeopardy, you make bets on titles such as Chicks Dig Me. You get questions that are actually, you have to guess the question for this answer, and it's very cryptic crossword-like. It requires a very sophisticated and subtle understanding of English language. It requires a very big database of knowledge. It requires you to apply context in a way that we would have thought computers couldn't have done. But in fact, IBM's Watson machine did win at Jeopardy, beating the two world champions of Jeopardy quite handily. So how could it do that? Well, what it did was it broke down each question in parallel into thousands of hypotheses, and then cross-tabulated them against an incredible database of knowledge, and then ranked them in terms of probability of which one might be the most accurate one. And in fact, this is eerily, and in fact, it's not just eerily similar to the way that human information processing works. It was modeled directly on an attempt by IBM to do inside a computer what is done inside of a human brain every time we try and understand a question or we think about something. We think we've only got one channel of thought, but really there's thousands of things going on in parallel as we try and work out what a sentence means or what this object is or so forth. And how could it do this massively parallel processing? Well, it used, obviously, IBM hardware, but the software in there was a software called Hadoop, which was running inside of this cluster on 3,000 CPU cores, and each question was processed in parallel, broken down into thousands of hypotheses, ranked within seconds, coming back with most of the time the correct answer. So this thing Hadoop is very important in artificial and collective intelligence. So let's talk about where it came from, because Hadoop is really the key technology in big data today. So Hadoop had its origins in Google, and Google, if you think about it, are the pioneers of big data. Everything that most companies today are only just starting to deal with, Google was dealing with more than a decade ago. The number of websites that existed were growing exponentially from the beginning of the World Wide Web, and it was Google's mission to try and index them all. So they had a lot of scalability challenges. When they started off, they just had bunches of servers under a desk, just as anyone would. This is literally Google's first system, but pretty soon they moved to banks of computers, banks of blades in racks, as you would expect. And now they've moved even beyond that. But when they get new systems built in, they get them brought in by a shipping container worth of servers. So this is a Google shipping container server. It's the size of a shipping container. It's got its own air conditioning and power supply, and it's got banks of servers inside it. And when you're inside one of them, this is what it looks like. And obviously, with millions of servers, servers are breaking down all the time. So people are coming into these server containers and swapping out the broken components pretty frequently. And when Google adds capacity to their data centers, it just piles up these shipping containers with more and more servers. Absolutely amazing stuff. And Google has, we think, at least a couple of million servers in its grid at the moment. So it's pretty obvious that this sort of hardware architecture did not have any sort of software that could run on it. There was no database that could run on this sort of hardware. So Google created their own software layer. So they took all of these servers, each of which had a couple of small disks in them, and over the top of these servers they created a thing called Google File System, which made all of this data look like a single addressable file system. And then they built their applications on top of it using things like MapReduce, Bigtable. And we'll talk a little bit about some of these technologies, but very, very quickly, MapReduce is a term you might hear, and that's simply the way in which Google breaks down a problem into multiple parallel streams. That's the map stage. We just map it out into multiple threads and then reduces as we pull it back in again. And we can go into more complex MapReduce where there's multiple mappers and a single reducer. And you can do quite complicated processing using MapReduce. It turns out that a lot of problems can be solved in this way. So you can sort of use MapReduce to run on these massive clusters quite easily. And Hadoop essentially is an open source implementation of this MapReduce stack that was pioneered at Google. And so the biggest Hadoop cluster are at Facebook and Yahoo. Yahoo, who were competing with Google, pioneered or supported Hadoop in order to get the sort of capabilities in Yahoo that Google had using their own MapReduce stack. And the Hadoop cluster at Yahoo has 4,000 nodes at least, 16 petabytes of disk, and that's even probably an old number. I think it'd be close to 50 petabytes now. 64 terabytes of RAM, 32,000 computer cores, all of which can be put to a single job if necessary. And since Hadoop was emerged a few years ago, it's been rapidly adopted by a lot of companies. Almost all Web 2.0 companies use Hadoop as part of the infrastructure. Almost all financial companies, almost all big retailers, most media companies. In fact, most large companies now, I would say, almost all of them have a Hadoop project going because the capabilities of Hadoop for big data are just so compelling. Another thing about Hadoop that's important to realize when we compare it to a data warehouse is it has this notion of schema on read instead of schema on write. So if you think about the traditional ETL cycle, we have some data, we extract it, we transform it, that is, we get it into normalized form, we clean it, we eliminate redundancy and so forth, and then we load it into the data warehouse. And those sorts of ETL projects, they take at least 6 months, often more, before you can then use the data. And often by the time you've got the data loaded, it's too late. The question has moved on. We've lost our time window. But with Hadoop, we can just load it directly into Hadoop without any transformation whatsoever. That's why we say that Hadoop is unstructured data. It's not that there is no structure, it's just we don't have to define the structure when we load it. So this data that's coming in at more and more velocity can be loaded into Hadoop, and then you can come back to it when you've got time or when you've got the need, and then you do the analysis of it, the cleansing, and utilization of it. And although it's true that you still at some point you have to work out the structure in order to use it, at least you don't have to delay the loading or the capture of the data while you're analysing it. You can load data at very high rates, store it in Hadoop very economically, and then you can come back to it if you need it. Hive is an important technology you might come across in Hadoop. Hive really solves the problem that MapReduce is hard. So this isn't, in this picture, it's not Hadoop MapReduce, it's MongoDB MapReduce, but it's kind of the easiest MapReduce of all, actually. It's done in JavaScript. But you can see here, this is the MapReduce that's equivalent to the SQL on the left. And for those of you who know SQL, you're probably going, wow, that's a lot more complex. But this is easy MapReduce. MapReduce in Java, the same thing would probably fill up this whole page, just to do a simple SQL statement. So Hive solves this problem because in Hive, someone like me, and that is what I look like if you've never met me, would submit a SQL statement to Hive. Hive will then generate the Java MapReduce code and send it to Hadoop, which will execute the SQL statement and bring it back to you. And so Hive is opening up Hadoop to traditional data warehousing tools to the sort of to allow us to use SQL, a language that we know, to get at data that is stored inside of Hadoop. So we have this big data stack, and we've gone over it in a bit, but the key technologies are that we have HDFS, the Hadoop file system, MapReduce for processing. We have these other technologies, some of which I've talked about, Java APIs, Cascading, which is another Java API, Pig, which is something similar to Hive, Hive itself, R, the statistical analysis package, works with Hadoop, and a thing called Mahout, which does some machine learning, and lots of other technologies aside, which we don't have time to talk about today, but all of which are fairly complicated to use. Hive is the easiest of all of these, but most of these tools require a lot of sophistication, not just sophistication in programming sense, but you need to understand the machine learning algorithms, statistical techniques, and so forth. And so to work this stack and to get some business value out of it, really we're relying on a new job role that we call data scientist. And a data scientist is a sort of a mix between a statistician and a programmer, someone who knows enough about programming to work their way through all these APIs, but knows enough about statistics and business analytics to get value out of it. And so the companies that are starting off these Hadoop projects are really struggling to find data scientists to make them succeed. And here's what I think a data scientist might look like. There aren't that many of them. You could think of data scientists as, you know, today's equivalent of rocket scientists. And if Hadoop projects are going to rely on a data scientist or a sort of like a rocket scientist with a funny hat to make them successful, then a lot of them are going to fail. So what we as an industry need to do is replace this data scientist with a software layer. That's the way that we move forward. We don't just keep relying on people learning more and more arcane skills. We abstract the problem with software, and this is why you'll see so much talk about big data analytics in BI today, because the need to replace the data scientist with some software that is more usable to a wider group of people is absolutely critical to the success of today's big data movement. So a big data analytics platform, what would it do? Well, here's some example terms of stuff that fits into the realm. These are all different sorts of statistical, machine learning, and business problems that can be solved in big data that today really require a sort of a data scientist persona, but which we're hoping in the future will be solved by software. So to wrap up a bit on Hadoop and then spend a little bit of time talking about what Dell is doing for big data, Hadoop is economical. Sorry, I think we've missed the slide there. I'm sorry, there's a chart missing there. Hadoop is economical in the sense that the storage cost per terabyte of Hadoop is a fraction of what it is for a relational database. So you might even say it's an order of magnitude less. So you can store petabytes of data on Hadoop for a fraction of the cost that you would have to pay to store them in a relational database. It's a scalable solution. It's been proven at Yahoo, Facebook, and other companies, and we know that can handle as much data as most of us are ever really going to push into it. We know that Hadoop can do complex analytics. It was the basis for Watson. Most of the machine learning techniques that exist have been used on Hadoop, so we know that it can answer the questions. Not that it's necessarily easy, but we know it can do it. And it's got the ETL free. It does not require us to go through long ETL projects in order to get the data in. So that's why Hadoop is the most concrete technology behind the big data revolution. And it's the one technology that all the vendors have stopped fighting against, and we're all consolidating around managing Hadoop and making it better. And it's going to be a technology that's going to be increasingly relevant in all fields of business intelligence and data warehousing going forward. But it's not everything. For instance, it's not a replacement for relational databases. No one thinks that Hadoop is going to replace Oracle. What will happen is that in most cases, the best practice for data warehousing will be to have a Hadoop cluster and an Oracle cluster, or Oracle or whatever your data warehousing system is based on, but have a relational database and a Hadoop cluster side by side, each of which is dealing with different types of data and different types of needs. It's not suitable for OLTP. You can't. Everything in Hadoop takes a few minutes to run, generally speaking. It's a batch system. It's long-running queries. It's not HANA. It's not instantaneous results. And it's not a complete solution. Hadoop on its own is only really going to solve the storage and raw processing requirements for your big data project. It won't on its own give you the business value that you're looking for out of big data. So let's talk about Dell and Quest software for big data. At Quest, we were doing a lot of work in big data since at least 2010. We have a product called Toad for Cloud Databases. It's a freeware product that supports a variety of non-relational systems. It allows you to do joins, for instance, in SQL between things like Hive and things like Oracle or MySQL or SQL Server or what have you. And we'd also built a connector between Oracle and Hadoop that was very fast, 5 times faster than the native alternative. And we used these technologies when we were building up our BI suite. The Toad BI suite that was released earlier this year incorporated a lot of the stuff that we'd been working on for Hadoop and big data for years and years. And as a result, our BI offering has very strong native capabilities in Hadoop and in other non-relational systems that are related to Hadoop, such as Cassandra. So what's the story with Toad BI Suite? I'll just give you the quick pitch for it. Our perception of the BI market was that there was a tension between corporate BI and end users. So corporate BI, systems like Business Objects, Salesforce, Oracle BI, IT liked them because they were compliant, they were consistent, they were secure, and they were sanctioned at the highest level of the company, and they were giving the company single versions of the truth and things like that. But the end user found them overly aggregated. Some of the detail had been lost during the process of making it consistent. It was restrictive, and it was costly on a per head basis. Not everyone could. It was hard to roll out to every user because of the costs, licensing costs for it. So a lot of end users were attracted to self-service BI solutions such as ClickView. And they found those were flexible, cost-effective. They would allow them to do agile. They could answer questions very quickly as soon as they thought of them. They didn't have long cycles to wait for new dashboards or something. And they could go down to the level of granularity they needed. But IT really had a problem with this because these were new islands of information within the enterprise. They were insecure, they were inconsistent, and they were unmanageable. So we set out to try and resolve this through Toad BI. And with Toad, we've tried very hard to make it something that still has the advantages of self-service BI in terms of flexibility, levels of details, and so forth, but which can be compliant, sanctioned, and consistent from an IT point of view, and so that IT can feel comfortable with rolling out this sort of self-service Toad solution to their end users while still knowing that they've got some manageability, consistency, and control. And so Toad BI Suite is made up of 3 central products: Toad Decision Point, Toad Data Point, and Toad Intelligence Central. Toad Intelligence Central is the hub around which we consolidate all our data. It knows how to talk to business intelligence systems such as Oracle. It knows how to talk to relational databases such as MySQL, SQL Server, and it knows how to talk to big data solutions such as Hadoop. And it has a security model within it so that you can control who gets access to what, and it allows collaboration, which allows you to share your views of the data with other users in your work group and so forth. Toad Data Point is the tool for the data analyst, the person who's very comfortable with SQL. It's got thousands of users. It's been out in the enterprise for many years now. It has some automation capabilities, and it helps you do collection, cleansing, setting the data up. For the analytic consumer, who would be the line of business owner, and this Toad Decision Point product allows them to do drag and drop analytics and to explore the data using the same data sources that were collected by Toad Intelligence Central and Toad Data Point. We recently announced our first big data analytics capability, Katenga Analytics. Katenga was an acquisition that Quest completed just before Dell acquired Quest. And it's a true big data analytics platform. And this is the platform that we are building to try and solve the problem I talked about before, the problem that data scientists are in too short supply. We need something that can be used that's accessible to a more less sophisticated end user. And so Katenga is designed to work with these big data sets, predominantly with Hadoop, that are at a very high volume, velocity, and variety of data, very, very oriented towards dealing with unstructured data, full text search, data mining, and so forth. So the way in which you build up some of these complex analytic workflows in Katenga was that you drag and drop individual processing elements. Instead of having to write thousands of lines of MapReduce code or fiddle around with Mahout or what have you, you would just drag the element you wanted on, you track pipelines of data, and then from there you could build dashboards like this search portal where you can then explore the data that the outputs of your data then can be visualized or searched or otherwise analyzed. Katenga's been used in pharmaceutical and healthcare to create searchable portals on drug formulations and other medical data so that you can search through scabs of unstructured data to find all the occurrences of a particular pharmaceutical element, to work out what geographies are being used to correlate occurrences of side effects and so forth. And it's also been used very successfully in government and public sector, things like sentiment analysis, trying to look for fraud and signs of anomalous activity, again, because it's very, very good at searching through large amounts of unstructured data. So here's the big picture of Dell's, and this is one of my final slides. Here's the big picture of how Dell's working with your big data and with all your data, really. So we have the world of the relational database that we all know about, the world of corporate BI, things like Business Objects, Salesforce, Oracle Business Intelligence, desktop data sources, Access, Excel, MySQL maybe, and the new emerging NoSQL systems, of which Hadoop is undoubtedly the most important. And with Toad Intelligence Central being able to connect to all of these, you can get a consolidated view of all the data spread throughout all the different types of systems that might be holding it. And as I mentioned before, we have tools for the data analyst and for the decision maker. And with Katenga, we've plugged in the data science capability required in the big data world, and we'll be integrating that with Toad Intelligence Central as well, so that from within this suite, you'll be able to solve all of your big data and traditional business intelligence needs. And I would be remiss if I didn't remind everybody that Dell, of course, is a hardware company as well, primarily a hardware company. And Dell is one of the major providers of hardware for Hadoop. We have a Hadoop solution where we can deploy for you your Hadoop cluster. We have software to help it be configured. We have a services offering You can start small with the Dell Hadoop solutions and grow as your data grows. And we partner with Cloudera, the leading distributor of Hadoop software, to do that. And it's a very appealing option if you wanted to get started. If you want to get started with Hadoop, Dell's a great way to get started. And then if you think about Dell together with the Quest software portfolio, we now have floor-to-ceiling capabilities for big data. We can give you the hardware, we can help you deploy it, and then we can help you make a success of it through data management capabilities and business intelligence. Okay, so that's my talk. I hope you found at least some of it interesting, and we'll open it up to questions now.
Thank you, Guy. It was a great presentation. Now we'll start going into the Q&A with Joanna, and I'd like to remind all of you attending that you can submit your questions in advance using the questions feature of the webinar software.
Oh, hi there. So we're getting a few questions. Feel free to ask me more questions through our chat box. Our first question is, what will become the role of the RDBMSs in the world? And as Guy said before, we don't expect any of these sources to go away from our perspective, as both Guy and I have been around for quite a long time. Data warehouses will continue to proliferate and become very pivotal points of content and analytic environments for us to delve into. But the reality is that, as Guy's first part of his presentation said, we just have such a variety of content today that the relational warehouses represents only one pillar of many of our organizations' data strategy. And so the Dell solution really addresses both the relational role, which is data warehouses, as well as a variety of ERPs that are built on top of relational marts, as well as really the support of traditional BI tools that leverage these relational sources. So the Toad BI suite, along with the Katanga Analytics suite, looks at all these sources as fair game for content, right? Those of you who have spent many months and cycles building these metadata models within these proprietary systems of Oracle BI or SAP's Business Objects Universes, we know that there's a tremendous amount of business acumen really trapped in some cases, but also stored and secured in these environments. So both of the suites that we just discussed, the Katanga Analytics suites as well as the Toad BI suite, can actually allow you to combine your extremely high valued structured content with your somewhat lower valued but still illustrative unstructured content to derive greater business insight. So the role of the relational source continues to persist in the environment and will be a huge part of your data infrastructure, which means that we will continue to support all the versions of relational data sources that are available as we do today. We had another question around, we had actually a lot of questions and many more questions than I can take today. So what is the relationship between Toad BI to big data? The Toad BI system actually is one of the only systems that will allow you to combine big data sources such as Hadoop, Cassandra, MongoDB, as well as other, including the Google sources, to combine that content with your relational sources if you so choose. So we're looking at the Toad BI capability to enable you to do analytics off of these larger sources. We're not expecting you to replicate your big data sources within the BI suite, but we are expecting that you would be able to take a query and ask that question of the HDFS and get a return of the content, and a subset of that information is then stored in memory or persisted inside the BI suite so that your analysts can do some analysis against that content. We had another question on how can an analyst take advantage of big data to provide business value? Well, that is quite an open-ended question. We are seeing, as you saw, the two examples around a pharmaceutical company as well as a foreign administration. We are also seeing companies looking at the Hadoop and big clusters of data around Twitter, Facebook, and web chats and website analysis, where we can combine all of that big data using the Katanga Analytics Suite and do sentiment analysis. And you can better understand how your customers are behaving, how your products are viewed, how your organization is viewed, for example. We have another example of a port of call where this particular company was really looking at the origination of particular manifests on particular boats that were supposed to dock within their port of call. And as you can imagine, boats coming from different places have different ERPs that are not necessarily accessible to this particular port of call operations. So what they did was they were crawling different websites for these particular companies and their systems of manifests, which is oftentimes just PDF files, and being able to correlate the manifest with the arrival time with different boats and different dates so that they could better optimize how the different ships got moved into the different berths. And that wouldn't have been possible if we couldn't do natural language search, pattern recognition around these large clusters of data. Really, they're only looking for key things that could optimize their performance. So as we evolve these big data use cases, check back to the Katanga site to learn more about how other organizations are leveraging their big data to derive operational excellence, as well as to become much more proactive and prescriptive in their ability to run their companies. I think I have time to take 2 more questions. One other question was, let's see, I have to scroll up now. Going down. Oh, how can you manage divergent data without a data warehouse in place in the organization? Well, that's an excellent question. As in the past, we always talked about having a data warehouse as a structure that was required to do performance management. Well, today we know that performance management with a data warehouse, and in many cases, is a slow development process. So we are seeing customers create, what I would call in-memory analytic marts. So the Toad BI suite could actually be leveraged to combine your heterogeneous source environment and stage an analytic mart that can then be pushed into your enterprise as a collaborated view on combined data. Without a data warehouse, I do see that oftentimes where customers are just determined not to roll out a data warehouse for exactly the reasons that Guy gave, which is the process of building a data warehouse has a great deal of latency. And some organizations that are really what I would call e-commerce driven, daily type organizations where the turnaround time for this type of analytics is very fast are looking to answer questions fast. The Katanga Analytics Suite could really be rolled out here to help you understand how your big data sources through natural language and pattern matching and source criteria, how your organization is moving and shifting with the times. I really can't answer very well in terms of how your particular organization might run without a data warehouse in place, but feel free to reach out to me if you'd like to have a conversation around how we view these overall solutions in the future for these in-memory as well as these analytic virtual layers. As Gartner says, a lot of customers are going towards the analytic virtual layer of data warehousing where you really are not persisting a somewhat monolithic solution of a data warehouse, but you're creating these agile analytic virtual layers which combine many sources of content to answer very specific performance answers. So we have a couple of analysts at Gartner that subscribe to exactly this, the solution that you're alluding to, which is how do we manage an organization without a data warehouse. So let's see. I had a question that says, as a business analyst working with business stakeholders eliciting requirements, is there something you think I'll need to do or think differently when helping organizations to extract value from tools like Toad BI? Yes, well, we know, and thank you very much for the question. We know that a big part of building these business analytics models as well as these business analytics structures really focus on understanding how your organization runs. And that is a very conversational activity. So as you start to, we've noticed some of the best practices from some of our organizations is as they start to derive the requirements for the different models that they're going to be building, either through a tooling such as the Toadbase suite, or even through Excel or other database type activities where you're creating marts. More and more we're seeing this need to be very open and very collaborative. They're looking at how supersets of content can be built where multiple questions which have similar tones but have different sources become very interesting to different groups had they known that they had them available. So an example is we had several higher ed organizations come to us where again they didn't have a data warehouse because higher ed tends to have very disparate and siloed departments. For example, the law department really is not interested in what the medical school or even the biology department is doing with their data. But it was very interesting that they learned that they needed to have the ability to share student data with these different departments and how their student scheduling worked. And so as they were collecting their requirements, they started to look at the questions from this perspective of how they could collaborate between departments, even though collaboration before was not a point of interest. And once they rolled out a superset of the content, it turned out that the law school was actually interested in the biology students' calendars because it actually affected which law students were pre-med and which had biology degrees, but they were still interested in law. And so it turned out that the ability to collaborate on the information was very important. So as you start to gather information around the requirements for building these infrastructures, I think collaboration is something to keep in mind. I think different ways of rolling out content is important, especially in different organizations that are adopting mobility. And I also think that with the advent of these large clusters of Hadoop data, you're looking at NoSQL as well as SQL sources that you may want to add into your infrastructure so that you can be more agile and be more flexible. So I'm coming to the end of our hour. I'll take one more question, which is how do I get access to the Katanga Analytics Suite? The answer to that question is, again, feel free to go out to the Quest.com website. It's still Quest.com, even though we are owned by Dell, and go to the Katanga Analytics Suite and please fill out the contact me form and someone will reach out to you. The product is available today, but again, we'd be happy to chat with you about the overall solution and give you a better sense of where you're going with your big data requirements. For the questions that I didn't answer, I will be taking them down and we will get back to you shortly. So thank you for coming, and everyone, hope you have a nice day wherever you are.
Thank you, Joanna, and thank you, Guy, for a very informative presentation. Thank you to everyone for attending today's Modern Analyst webinar. I wanted to point out the webinar, along with the slides, will be archived at the ModernAnalyst.com site within a few days. So this concludes today's event, and we hope you have a great day.